Hello everyone. Welcome to the Internship Studios session on Introduction to Cloud Computing. I am Shuling Patil and I'll be the instructor for your session now. I hold around 2 years of experience in the cloud computing and DevOps industry. I am currently working with a United States based product based organization from the past 4 months. I helped enterprise organizations migrate to cloud computing from their on-premises and data centers using the help of Google Cloud and AWS, and also leveraging modern DevOps tools such as HashiCorp, Terraform, and Packer, uh, containerization tools, Docker and Kubernetes, and cloud providers which are Google Cloud and Amazon Web Services. So I hold technical wisdom so that I can deliver the session very interactively for beginners. Also, for your information, I am certified across multi clouds. By Google Cloud, I am certified as a professional cloud DevOps engineer, as a professional cloud architect, and an associate cloud engineer. From Amazon Web Services, I am certified as a cloud practitioner. From HashiCorp, I have been certified as a Terraform associate. And from Microsoft Azure, I am certified in Azure Fundamentals. So, hope you had a good overview of my profile, and I once again thank you for attending this session. So, let's start. Firstly, we'll go to the introduction of the session, which is Introduction to Cloud Computing. So, initially, we'll go on the definition, which is provided officially by Amazon Web Services. So, what is cloud computing? So, as the definition says, cloud computing is the on demand delivery of IT resources over the internet with pay as you go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as needed basis from a cloud provider like Amazon Web Services. So, let's dive into the fine details of the definition. So, let's dig deep into the definition of what we just saw it. So, the first adverb or phrase that you see is the on demand delivery. So, in the world of technology, on demand delivery means getting things right when you need them. It's like having a magic service that brings you whatever computer power. For example, your personal machines. You are sitting at a home and you need 10 computers at once. So, but in a physical scenario, it's uh, not the situation. Like you have to purchase, you have to go to a shop or something, or you have to buy it online or wait for some days. So, in simple terms, you don't have that instant availability of a machine or a computer right next to you. But that's the superpower of cloud. If you can see, it's at right at the fingertips that we can have as much as you want. I'll give another simple example. Like, think of your favorite pizza delivery. So you don't have to buy the entire pizza shop, right? You just call and your pizza arrives when you want it. So on demand delivery is like that. It's just a bit like that. But instead of pizza, it could be your extra computer or storage space for your projects, any project you have. So on-demand delivery is like having a magical service that fulfills your request instantly, like in a matter of some microseconds, just like pressing that special button. So it makes things much more easier and more convenient in the cloud computing space. to have like enormously huge computing power in the palm of your hands. Coming to our next keyword, on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So here you should definitely look into the pay-as-you-go. So I'll give an example like think of your mobile phone plan. So you do your normal phone recharges. So if you pay as you go, you might buy credits for calls and texts, for example. So it's a model such that you only pay for the minutes or text messages you use, like not a fixed amount every month. I'll give the plans we have currently in India, for example, Jio or Airtel. You come like you already pay a fixed plan of around 600 rupees upfront, so that you no need to bear them for rest of the 3 months. But how about an idea where you could pay only for the seconds you had called? We call it talk time plans right here. So yeah, that would be the model that the cloud currently uses. Like we only pay, like in the tech world, in terms of Amazon Web Services, for example, in this cloud computing, it means you only pay for the computer power, storage, or services you use. Just like you only pay for the ice cream scoop, for example. Like for example, in a ice cream parlor, if you go, you only pay for only one scoop, so you need not bother about rest of the amount or how much you are consuming. I think you got it. So yeah, with these two examples, I think you got an overview of uh, what the definition says a lot. It's just like renting resources from someone and over the internet and just paying for whatever the resources we use, instead of owning all the things, or like all the physically computing things like uh, virtual machines, storage, and databases required for spinning up a web application or a mobile application. We'll go deep into the technology later, but I think this is enough for your first definition. So, coming to the next uh, points, which are what is a data center and on premise means. So, let's go into the definition. A data center is a physical location that stores computing machines and their related hardware equipment. It contains the computing infrastructure that IT systems require, such as servers, data storage drives, and network equipment. It is the physical facility that stores any company's digital data. So, to give a bit of context, a data center consists of very powerful computers, servers, and networking equipment neatly organized in racks. So I'll show you a picture of that in the next slide, but I'll just give an descriptive overview currently. So these machines work together to store, process, and deliver digital data, like which act as a backbone of various online services we use in the current world actually. So functionality wise, you can imagine them just as library stores, which have multiple books for easy access. So similarly, a data center stores and manages data, making it accessible to users across the internet. So it handles everything from hosting your websites and applications to storing massive databases. So I'll give a couple of examples where a data center will enable. For example, we have this website hosting. So imagine you want to start a blog, like if you have a passion for writing some blogs regarding tech or lifestyle or health, whatever. So instead of keeping your blog posts on your personal computer, you can store them in a data center. So it would be more safe comparatively. When someone access your blog, like from the global perspective, from anyone sitting in US wants to access your blog, then you can just the data center swiftly delivers the content to their device. So that has been made possible by the advent of data centers. And also in our modern times, we have these streaming services. For example, when you watch videos on platforms like YouTube or Netflix, The smooth streaming experience is made possible by these data centers. There are millions of concurrent users watching at a single time, and these data centers have that massive scalability and technology to uh, make that possible, that of people can watch their favorite movie at once. So another example I can give is cloud storage. So for example, if you have an iPhone, so we have the iCloud storage. So which is like a virtual storage. It's not present in a physical phone. So we also have, like, you may have heard of Google Drive for Android phones or PCs, or Dropbox, which is a third party service for storage. They also utilize these data centers. Instead of saving files only on your computer, you can store them in the cloud, making them accessible from any device connected to the internet. So I'll explain what on-premise means in our next slides. So coming to what is on-premises in the context of cloud computing. So as the definition goes, an on-premises data center is a group of servers that you privately own and control. Traditional cloud computing, as opposed to hybrid or private cloud computing models, involves leasing data center resources from a third party service provider. So let's dive deep into this definition. So think of it like you have your own personal gaming console at home. So all your favorite games, saved progress, and gaming equipment are right there. You don't need to go to an arcade or borrow someone else's console. Like, you are in charge of the whole computing machines. You can customize whatever specifications you want, be it the storage, the database configurations. Everything is custom built for you. So you can match all those configurations and specifications according to your application needs. So it's like privately custom building an data center to cater to your application needs. Uh, so we'll go deeper into the evolution of cloud computing to what it has become in the modern times. So it goes back into the 1960s, uh, which started as the conceptualization of time sharing. So the idea of time sharing mainframe computer emerges, allowing multiple users to access a single time simultaneously. So this concept actually laid the foundation for the shared resource model, which will come later in the next sessions, which was a precursor to the cloud computing. Uh, because you can see that computers in the 1960s were powerful, but they are quite rare because people didn't have that much money to afford these expensive computers, since technology was still becoming a thing that time. So time sharing was the method actually to share these precious computing resources among multiple users. So there was a methodology of dividing the time slices, just like we in the library, the librarian, we have those concept of dividing the time for readers for a specific book which is very rare uh, to read actually. So similarly, that computer would be split like into multiple time slots in a day, because each user has got the time to use that computer for a specific period of time. So actually in the 1960s, time sharing was a smart way to let many people use a computer by dividing its time into slices. Like, for example, a person A got to access for to use the computer from 12 p.m. to 1 p.m., and person B got time to use the computer from 1 p.m. to 2 p.m. similarly. So this pretty much explains, I think, the concept of a shared resource model where a single object is used by multiple users. So coming straight to 1999, so Salesforce introduces as, like, Salesforce is a multinational company which pioneers in many products. So they thought of this idea of a software as a service model by delivering enterprise applications over the internet. So SaaS, I'll explain you deeply in the next slides. For now, you just be aware of this. So they made a shift from traditional software distribution to subscription-based on-demand service. So, for example, we have in our current times we have this Prime Video from Amazon, where we need to pay certain amount to access their content, right? So, similar setup they had set up in the 1999s. Uh, Coming to the next slide. So, going to 2002 here, Amazon Web Services launch. So, Amazon, you may have heard of Amazon, like it's an e-commerce application. So they have this both web application and mobile application, which helps customers to shop whatever products they want. So it was the for brainchild of Jeff Bezos actually, who was the founder of Amazon, to launch Amazon Web Services, which has laid the foundation of this cloud computing market we have today. It's a multi-billion-dollar industry. So they started this idea of offering computing power, storage, and other IT resources as a service over the internet. So AWS becomes a key player with the first more advantage and a driving force in popularizing the infrastructure as a service model. So coming to our next point, in 2006, uh, we had the introduction of cloud computing terminology for the first time. So it was Google CEO Eric Schmidt who introduced the term cloud computing at an industry conference. So the term finally got widespread acceptance. Like people got hinged into this buzzword, and it became a standard way to describe the delivery of computing services. Like it's kind of a rental services of computing power from giant organizations to small and medium scale industries to take over the internet in the future. And in coming to 2013 with the rise of containers with Docker. So Docker for now you can uh, get to know that has a containerization tool. So no need to go deep because it's a separate technology altogether, which helped developers to package their applications and move it to production. So for your context, here is a small definition. Docker is an open source platform for containerization. It was released in 2013, which revolutionized software packaging and deployment. So from 2013, you can see that containerization became a key technology in cloud computing. So enhancing portability and efficiency in application development and deployment. So coming to our next slide. So here is what a data center may look like. So we had a overview of in the previous slides about what a on-premise data center is. So the left photo gives you a glimpse of how things are inside a data center. So you can see those racks which are maintained by uh, high efficiency air conditioners to keep them uh, working 24 into 7 whole year actually. So these data centers are continuously cooled in an environment which is protected securely as well. So in the right side you can see this is a data center from Amazon Web Services, uh, in a simple terms by Amazon. So you can see all the servers and all are tightly integrated inside these buildings which are secure and being guarded by men actually to keep them safe from any attacks or other unforeseen events. So companies invest a huge amount of money in these data centers so that businesses who are investing their applications on cloud and all, so they don't get affected. So they take these configurations and setups very seriously and invest billions of dollars to always have these servers up and ready to uh, deliver their applications for their customers. So moving to our next slide, why do we use the cloud? So I'll be like from here on, cloud means cloud computing. So why do we need that exactly? The first convenience we have is accessibility anytime and anywhere. So cloud computing allows you to access your data and applications over the internet from anywhere with an internet connection. For example, just you have a laptop with a Wi-Fi or personal internet connected, you can just access a server from anywhere in the world sitting at your home or at a cafe or something. So it gives that super portable accessibility that you can leverage anytime. Just with an example, like just like how you can check your email from any device without needing to be at a specific computer. So cloud services are available wherever you go, just with an internet connection. So and the next big advantage is cost savings. Cloud services often eliminate the need for organizations or individuals to invest in and maintain their own expensive hardware and infrastructure. Example like instead of buying and maintaining your servers, you can use cloud services to pay only for the computing power or storage you actually use. So let me give an example. Uh, Imagine you are getting to have a small task done. So you have a friend who owns a MacBook Pro or something which costs 2 lakhs. But you don't have that upfront capital to do that task. Like you just need it for half an hour or 1 hour to execute some large video editing. So you can pay your friend around some 500 or 1000 to get that task small task done, and your work is done in around some small time. So this is an example you can relate. Like you need not particularly own a laptop, a MacBook Pro laptop to get that work done. So similarly, you can pay here for the Amazon Web Services, where you can give only pay them for whatever the compute or storage services you have used in their website. Moving to the next slide, the next good feature of cloud computing is scalability and flexibility. So cloud platforms allow you to easily scale up or down based on your needs. So by scaling up or down means uh, the requirements, like if you have a requirement, for example you have a requirement for of around 100 machines and you want to scale that up to 1000 machines, you can do that also with the help of cloud. And you are not, and your application, for example, it has a slow traffic and you want to reduce the number of machines serving that application to 50, you can do that also by using cloud. So it provides that flexibility to handle changes based on your demand. For example, if you're a business, you can quickly adapt to increased website traffic during a sale and then scale back when the promotion is over. For example, so in this scenario, for example, you have this Mintra app. In India, we have a app for shopping, Flipkart and Mintra, right? So they hold a couple of sales actually. In a year, there will be 3 or 4 sales. For example, this Big Billion Day. So there, the traffic will be huge for that application. So millions and crores of people will be using that application during that. So there will be actually to for your information, these applications are also hosted on the cloud in these modern times. So if there are millions of people accessing that application at a given point of time, then also that application will not crash. So that is the advantage of cloud. So they are already hosted in Amazon Web Service or Azure or Google Cloud, so that uh, their business is not affected at any point of time. So hope you had an idea here. So coming to next advantage of cloud, these are automatic updates and maintenance. So you already know that computing power is nothing but these machines, servers, you mean computers. So these cloud service providers that we have, for example, Amazon Web Services, they take care of all the software updates, security and maintenance, freeing users from these tasks. Taking example from your own laptop only, like if Windows releases a update to version 11, so you have that headache of going to the internet, downloading that update, and again installing that, and again restarting. And also, you have those security updates for keeping your computers from outside attacks. And other like normal maintenance, for example, if you have SaaS applications like Microsoft Office 365 or Slack or some other applications, you need to regularly update them so as to be secure all the times while using them. So also like it will ease our processes, actually ease our mm, routine tasks, so that there is smooth workflow at all times. So but here it's not the case. These Amazon Web Services, they take care of all the updates or security and maintenance related things. So we just spin up the machines and go from there. So the next good advantage is collaboration and sharing. Cloud computing facilitates easy collaboration by allowing multiple users to work on and share documents or projects in real time. So, for example, since it's virtually possible to spin up a machine, you can easily collaborate from people like sitting all over the globe. Like I have been I spinned up a machine like sitting from India on AWS, and I want to allow access for a person sitting in US. So with some online authentication, we can enable like cross collaboration from across the globe. So it helps us become a global citizen in case like if you want to collaborate with your team from across all over the world, it makes this possible. So, for example, we have this Google Docs. It is hosted in Google Cloud only. So, Google Cloud is one of the cloud providers nowadays. So, it has this feature called where multiple people can edit a document simultaneously, making teamwork more efficient. For example, in Google Docs, if you just have the email ID of a person, you just can add him to that and he can access that file from anywhere across the world. Coming to next slide. So one more question that may pop up is, why should I care for the cloud industry? So the first main reason is explosive growth. So the global cloud computing market has experienced rapid growth, with projections currently reaching hundreds of billions of dollars. So the implication is that the industry's expansion signifies a high demand for cloud related skills and services, creating numerous career opportunities. So you can see like during the pandemic we had this massive breakdown in the IT industry, and lot of businesses were shut, physical businesses you mean. So what cloud enabled was like a massive digital transformation took place where like most of business went online. So you can order any, for example, a small food business you mean, so you can order a piece of that sitting at the comfort of your home. And we had all these delivery related businesses groom in that phase. Actually, we had the advent of this Blinkit, we have this apps called Dunzo, we have this app called Zepto, which all promised a 10 minute 10 minutes delivery of goods at the comfort of our homes. So these also uh, enabled more growth for the local people as well of those cities. And the second point is dominance of major players. So the fact is we have these leading cloud providers available in the cloud computing industry such as Amazon Web Services, we have Microsoft Azure and Google Cloud, which almost dominate the market share currently. So the implication is that working with these major cloud providers, they provide professionals exposure to cutting edge technologies, so and a chance to contribute to industry leading projects. So being in the cloud industry, so there is always something coming up, like every day, every hour. So there is innovation happening. So by joining the cloud industry, so you get a part of being in modern projects. So you'll always be relevant to the industry and not get mm, not get to work with old technologies which are deprecated very fast, and you may lose the jobs for those. Coming to the next slide, cloud computing is a very huge digital transformation catalyst. So the fact is, cloud computing is a key enabler of digital transformation for businesses across various sectors. The implication is that professionals in cloud computing play a crucial role in helping organizations modern their IT infrastructure, enhancing efficiency and competitiveness. Uh, you may like what I mean is you may take any sector nowadays. It may be financial technology. For example, we have this phone pay, Google Pay, and all. So these have enabled economies of scale, and like they have massively transformed how a normal person has he has been using technology in modern times. So we have that opportunity to also contribute to this to these digital transformations by being involved in the cloud computing industry. And coming to the next new feature, it is remote work facilitation. So the COVID-19 pandemic in 2019, so you all saw like many businesses shut shop. So it accelerated the adoption of cloud technologies as businesses shifted to remote work models. So one advantage and implication is that cloud professionals contribute to the establishment and maintenance of remote infrastructure at the comfort of their homes, so making their skills highly relevant in the current work environment. So having cloud skills will really put you in the map, and you can be always be hired for your skills, which are in high demand nowadays. And one more awesome feature is cloud computing is a major innovation hub nowadays. So because it is at the forefront of technological innovation, incorporating advancements such as artificial intelligence, machine learning, and the Internet of Things. So the implication is that careers in cloud computing offer opportunities to work on cutting edge projects which are still in the implementation phase actually. For example, you may have heard of AI. So it has been theoretically present from the past many years, but practical things are being enabled currently only because of this cloud computing. And also you can be part of the future transformations as well, where you can leverage cloud and AI to foster new innovations. These are the five benefits of why cloud is the next big thing. So coming to the next slide. So here I have taken an image courtesy of Statista, uh, where source is the Synergy Research Group. So currently we have uh, around 8 or 9 major cloud providers, where you can see these are this is a latest uh, starts of Q2 2023. You can see that AWS, which means Amazon Web Services, So this is the number one cloud provider currently with a market share of 32%. And Microsoft Azure, so which is by Microsoft, so they are holding a market share of 22%, and they are the second leading provider of cloud computing. And we have Google Cloud from Google, which is at 11%. So we have Alibaba Cloud, IBM Cloud, Salesforce, Oracle, Tencent. So at a high level, you can see these are the top Fortune 500 organizations which are involved in modernizing this cloud computing and other technologies. So this will be there will always be innovation in cloud, and there will be no dearth of jobs. Uh, and also you can see the cloud infrastructure service revenues is capped at $65 billion. So it is a very hefty amount if you convert it to Indian rupees. So coming to the next slide. This is a small image courtesy of Citrusburg, uh, which are all hosted in the cloud nowadays, which means which are powered by the cloud computing. So we have Salesforce application, we have Zoom, which has enabled us to collaborate digitally and do online meetings across the world. And we have G suite of applications. Google applications, you mean Google Docs, we have Google Chat, we have Gmail, we have Google Sheets. These are all are powered by the cloud. And we have Slack, which is also a collaboration tool. We have HubSpot, we have Shopify, we have SAP Concur. SAP all has around hundreds of applications hosted on cloud. We have Adobe Creative Cloud. We have Netflix, which you may all be familiar, which is a movie buff website which allows us to consume digitally curated content. And we have Atlassian Jira. So these all are applications, like every application you take in your mobile, maybe Flipkart, Myntra, it's powered by the cloud nowadays. So yeah, coming to next slide. Uh, there are a couple of core concepts of the cloud computing services. There are some terminologies that you may need to understand. So the first terminology that you need to know is PaaS. So it's PaaS. So it's in our layman we call it as PaaS. So platform as a service is a cloud computing service model that provides a platform allowing customers to develop, run, and manage applications without dealing with the complexities of infrastructure and hardware. In a PaaS environment, the underlying infrastructure, including servers, storage, and networking, is abstracted away, and developers can focus on building and deploying applications. Uh, the crux of this definition is it is has a service platform as a service. You mean like the developers, you mean the software developers we have who write code, they need not uh, be concerned about the infrastructure, like which uh, virtual machine or a computer I'm using, or what is the storage size, and which networking configuration it has. Everything is being abstracted by the cloud provider itself. So the only focus they can have is on building the application logic and deploying the applications. That's it. Everything is taken in the back end. It is taken care by the Amazon Web Services if you are planning to host it in AWS. Uh, yeah, this is pretty much about PaaS. And coming to next slide. So this is a tree of the three terminologies. So this is a table which we have to describe what different service strategy gives we can use by the cloud. So the purple color highlight is where you would be responsible of what all you will be managing as part of the cloud provider. and the blue is managed by the vendor. You mean, for example, which cloud provider you are using, for example, AWS, Microsoft Azure, or Google Cloud. So IaaS means by infrastructure as a service. PaaS means platform as a service. SaaS means software as a service. So in IaaS, you mean infrastructure as a service, you have applications, data, runtime, middleware, OS, virtualization, servers, storage, networking. So mostly the purple boxes, which are applications, data, runtime, middleware, OS, is managed by you, like you mean the customer, and virtualization, server, storage, networking is managed by AWS. You mean the vendor. Uh, Coming to PaaS, which is platform as a service, you can see that only applications and data related things are managed by the customer, and rest all the stuff, that is runtime, middleware, OS, virtualization, and other stuff, are managed by the vendor. And coming to SaaS, it's just that you are just writing your application logic and deploying it to the uh, cloud provider, and everything is taken care by the cloud provider itself. You are just focused on the application logic, that is the code of the application, whether it is a C hash code or a Python code or Java based application. So yeah, this is a informative table which will give us an overview of what different types of uh, has a service models the cloud has. So after we saw PaaS in the previous slide, so we have definitions for SaaS, which is software as a service. So coming to the definition, software as a service is a cloud computing service model that delivers software applications over the internet. In a SaaS model, users access software and its features through a web browser without the need to install, manage, or maintain the underlying infrastructure and software applications on their local devices. SaaS is one of the three main categories of cloud computing services alongside infrastructure as a service and platform as a service. So SaaS applications, you mean like the Google sort of applications that I showed in previous slides. For example, we have Google Chat, Google Meet, Gmail, which is we are just using them in our mobile devices. And if you want the elevated, like more advanced versions, only then you need to pay the Google for that, for any advanced features. For example, in Google Drive we have a storage limit of 15 GB. So beyond 15 GB there is the provision to use a business version of that. So for example, we have other SaaS applications like Slack, uh, and we have YouTube, which can be considered as a SaaS as well. So if you want to go for an ad-free version, we have this YouTube Premium, which Google charges, so that we can have provision of you mean background video playing and skipping the ads and other stuff. And coming to the first model, that is IaaS, which is infrastructure as a service. So this is the first and foremost deploying model of the cloud, which is a cloud computing service model that provides virtualized computing resources over the internet. In an IaaS environment, users can rent virtualized hardware such as servers, storage, and networking on a pay as you go basis. So IaaS is one of the three main categories of cloud computing services alongside PaaS and SaaS, as we just saw. So here there is a bit of overhead on the customer, where you are given access to the cloud, but you need to configure each virtual machine. So I'll be showing these how to spin up a virtual machine in the next AWS sessions as we move ahead. So just for info, you can understand this as where you will be configuring each and every aspect of the server, storage, and networking part. So it will be more control in your hand, so that how you can customize your application from the ground up. Yeah, coming to the next slide. So yeah, I think pretty much we had an overview of all the cloud computing concepts and how a data center looks. So before we go ahead, so here is a quick overview on what are the cloud computing jobs in the current market. For example, after you complete uh, these sessions on cloud and AWS, so what are the roles that would be suitable to get hired? So the initial one and entry level ones are as a cloud engineer. So cloud engineers are ones who design services which are suitable for deploying these applications on the cloud. And we have this title of DevOps engineer, which is a mix of developers and operations aspects. So he would be responsible for creating CI/CD pipelines or other stuff in the cloud. And we also have this SRE, which is a site reliability engineer. Actually, Google used these titles earlier, like in 2012 or 13, for keeping their websites very reliable at all times. So nowadays, you can see in all the job postings, we have this title as site reliability engineers. So they are responsible for keeping the websites mm, intact at all times. And after gain a bit of experience in the cloud, so we have the provision to become a cloud solutions architect. A cloud solutions architect will design an end-to-end solution for all the cloud-based applications, be it migration or migration from a data center to cloud, or from cloud to cloud migration. We have that uh, option as well. Like as you get to know more about the cloud, we also can migrate the applications from one cloud, for example Amazon Web Services, to Microsoft Azure or Google Cloud or any other cloud of your choice. And we also have this roles of cloud sales engineer. So once you're familiar with all the cloud related aspects and how it works, so you can also apply for cloud sales engineer, so where you can sell prospective customers about the advantages and benefits of cloud. So mostly Google and Microsoft have these type of job openings. And similarly, we have roles for cloud developer and cloud FinOps engineer. So cloud developer are mostly software developers who write code for applications suitable for the cloud. And we have this cloud FinOps engineer. FinOps means financial operations. So after this cloud has become popular, like it has been there here for around 10 years now. So financial management has become a thing nowadays, because after you jump into the cloud, one aspect that has come is cloud cost management, because you are paying for all the services that you're using, and you should be aware of what service costs how much money. So learning about the service is one thing, and getting to know how much one costs. So nowadays business can save a lot of money by getting to know what to spend for which service. So here a new role has come up, which is called cloud FinOps engineer, who oversees the cost of the resources of the cloud environment. And still, it's a booming industry, and there will be new and new roles coming each and every year. So you have chosen the right career path as of now. Coming to next slide. So yeah, that was pretty much the first session. A small introduction about uh, what is cloud, the definition, the concepts, the cloud providers, and different cloud service offerings. Like cloud providers we have, right? We had those, and the job roles that are currently available in the cloud market. So the next session would be about AWS fundamentals. So hope you had an informative session, and hope you helped. It. Hope the session helped it to brush your, uh, uh, knowledge, and to brush your, 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 uh, knowledge, and basics of cloud computing. So looking forward to see you in the next session. Thanks everyone for attending.